Okay, welcome back, everybody. This is the Virtual Residency Workshop 2026. It's Monday, June 22nd of 2026, and this is the fourth and final session of the day. This is the Cyberinfrastructure Landscape, and I'd like to introduce our speaker, Mike Renfro from Tennessee Tech University. Mike, take it away.
Okay. Thanks, Henry. And for those of y'all that are new to this used to be two 45-minute talks before they handed it to me. Now it's one 45-minute talk with the same content. So strap in. So, all right. So to give you an idea of how I got to where I'm at and some of the significance of this, my LinkedIn bio has all of this fancy language about decades of supporting engineering research. And it really comes down to the fact that 35 years ago, I was a poorly diagnosed, high functioning ADHD engineering student. And I probably should have spent more time studying than helping people in computer labs. But I lucked into a couple of years of co-op at Oak Ridge National Lab doing a mix of CAD support and Unix systems administration and some actual engineering across a couple of those years. That eventually turned into a bunch of degrees from that same university. I call it a master's in shaking things and a PhD in breaking things. I spent 17 years outside of Central IT as an R&D engineer in a research center, and I was the first campus-wide HPC administrator here in Central IT. I'm on way too many mailing lists and Slacks for different RCD groups. I was on Campus Champions leadership team for about 3 years, and I've been on CARC Emerging Centers for about 2 years, and I'm a compulsive advice giver and rabbit hole chaser. And so, for the folks who don't have a whole lot of time for the rest of this talk, or folks that can be overwhelmed by just the wealth of things that are in the RCD ecosystem, let me give you an idea of what other people have called the starter pack of organizations and conferences where you can find other communities and resources as you need them. And so, the first one is Campus Champions. Now, this I think was the second community that I joined around 8 years ago. This is the one that introduced me to Henry and a lot of his folks and others via virtual residency. And so Champions is one of the longest running organizations starting around 2008, formerly funded by an NSF predecessor of the Access program called Exceed. Has about 900 members from every state in the country, has folks from every RCD role, facilitators, software engineers, sysadmins, directors, everybody. Reasonably active mailing list and Slack, two regularly scheduled calls each month, one with a specific topic and an invited speaker, and the other one is just free form community chat sort of thing of any topic of interest. And so another advantage to Campus Champions is for those of you that are working with some of your researchers that get access allocations at any of the resources that are there. Being a campus champion gets you extra insight into their usage there so you can help guide them in terms of making sure they make the best use of the resource, that they use the GPUs they ask for, the memory, the CPUs, et cetera. Or you can help guide them toward more suitable resources for their work that way. The other major catch-all group for all things RCD is the Campus Research Computing Consortium, or CARC. And so CARC has a pretty comprehensive structure of tracks, of interest groups, and working groups that work on different things. These are all pretty much ad hoc and community driven. The tracks themselves tend to have only one scheduled Zoom call per month, with a whole lot of behind the scenes coordination going on, especially in the working groups. And the biggest thing that I'll give CARC credit for is for just this ongoing and totally unique and invaluable work in professionalization of our field. So helping us translate our research, computing, and data roles into job family matrices that will help you hire people if you're just getting an organization off the ground like I was. The RCD Nexus organization that puts together workshops and papers on workforce development and benchmarking your institution's RCD capabilities versus others. And you can use that to help prioritize where you want to focus your funds and your efforts in the future. Now, both of those organizations are all virtual, zero cost to join, individual memberships, basically, extremely welcoming and accepting to new folks. So by all means, hit up both of those. And Henry's got my slides, and they're on the webpage. All of these QR codes should be accurate. And if you get the PDF copies, all of the QR codes should also be clickable. to go to the actual organization in question. Now, if you got a little bit of budget and you're up for some travel and you don't know where to go to improve your RCD program or yourself, there's a few other options. And one of them, the Association for Computing Machinery, are there state level groups? Asks Veronica. And yes, but it's very hit and miss, and some of them are more regional than state specifically. I can find a few of those, but I'm going to go on from here. Also, Go Vols. I am from a different part of Tennessee, William. I did not grow up, in the shadow of Neyland Stadium, and so I accept your opinion. Uh, so ACM, PERC, Practical Experiences in Advanced Research Computing. This has been my top priority conference ever since I got to go to one back in like 2022. This is the de facto RCD people conference versus the stuff conference. There's probably going to be about 1,000 people there this year, at least 900. Um, it's small enough to where you can meet a lot of people doing the kind of work you're doing and not get completely overwhelmed. The conference is basically an academic professional conference. There's papers and presentation tracks. There's a poster session predominantly for the grad students, visualization showcase where people can show off their work and get ideas to take back with them. There's a full day of workshops included for tutorials on a huge range of topics, co-located events from CARC and RCD Nexus on the Sunday prior before the actual conference starts, and a great student program for your undergraduates and graduates. And I would say go to PERC at least once. But as I said previously, this one is the top of my list every year over any other conference I could attend for what I get out of it. Now, the most famous one on the other end of the conference spectrum, basically, is the Supercomputing Conference Series. And so, completely opposite experience in a lot of ways than PERC. That was around 18,000 attendees peak. I think that was 2 years ago. I think it was like 16,000 last year. Huge exhibit space, tons of vendors, tons of recruiting for graduate schools and national labs and everybody. One of the two top 500 lists for the fastest supercomputers in the world is always announced at SC every year. They host a student cluster competition every year. In fact, two different types of cluster competitions. Teams from all over the world compete to get the most performance out of a limited power budget and get the best performance on a range of computational codes. And that's a big brag for the kids as well. The SciNet network that covers the Wi-Fi and other networking for the exhibit hall and such is ridiculously over-engineered, gloriously over-engineered. They strung 29 miles of fiber optics and copper around that convention center last year. 14 terabits of internet bandwidth provided to the attendees and exhibitors, and that's per second, not overall. And so far, I've done one full week of SC attendance and one extra day of walking around the show floor in a previous year. And it is a lot, folks. Okay. And so for some of y'all, going once is going to be plenty. And you send somebody else that's more interested in seeing the hardware. But you may find out that you're the kind of person that wants to go back there repeatedly. But it is a much different experience. New to the list this year, and Henry and I and some others were there literally a week ago, is the Research Computing for Small Institutions, or RCSI conference. It's been around since 2020, held under a couple of different names. And the thing with this, and I don't know exactly who's in my audience here, but one thing to note in the broader U.S. higher ed population space and demographics, about 70% of the undergraduates in the U.S. attend a non-R1 university. I was one of them. Every student I know here has been one of them, because at best we've been an R2. Okay. A lot of these folks go straight into workforce after graduation, and we don't see them in grad school or in heavy research roles. But across all PhD degrees awarded a few years ago, about 30% of them, 30% of those doctorates got their undergraduate degree at a non-R1, anywhere from a small liberal arts college on up. If you just look at STEM PhDs, it's about a quarter. Okay. And so that's a substantial portion of your student user population at any university you go to, but that's also being performed without a whole lot of access to the funds that an R1 or a more established program might have access to. That leads to some unique challenges. And so, from personal experience, I thought me and my R2 was a small program, and I thought I was under resourced until I saw what some of these even smaller programs went through to get their work done. And there's a lot of common interests between and membership between the CARC Emerging Centers track that I'm on the steering committee for and the attendees of RCSI. And so there's some plans in the works to sort of refocus the Emerging Centers track to be a more year-round experience similar to the RCSI conference than it could offer on its own. And then the last thing on the list is for the starter pack is where we're at right now, which is Henry's virtual residency. And so I am super grateful to Henry and all of his cohort for helping me attend that in 2019 in person because, by and far the best value experience for RCD professionals, if for no other reason than if you divide your value by the zero cost it took you to get here, you get an undefined number. And if you're an under resource, if you are just getting started out, this is basically the place to be to get a lot better talks than I'm going to give about all kinds of topics. And so, past the starter pack, there's dozens, if not hundreds, of RCD and RCD adjacent groups, conferences, different things. There's some overlap. They've all got a little different focus priorities. So how can you make sense of them so you can direct your coworkers, your students to different ones to get the advice that they need? And so probably what I've done for the last few years is I've divided these up by what CART calls facings. And we've probably talked about that today. And if not, I'll know it'll show up later this week. But the biggest categories of work that RCD work sort of falls into. And so if you're working directly with facilitation and directly with your end user, that's researcher facing, trainers, onboarders, data facing for data collection, data management, archival, thing like that. Software facing for science gateways, software development, profiling, systems facing for my server nerds in the back room that don't want to talk to anybody, your network administrators, engineers, your architects, and strategy and policy facing for any of the folks that deal with leadership roles, institutional alignment, funding, external partnerships, things like that. And so for the researcher facing side, especially to use for introductory user training, software carpentry and the related organizations under the carpentry's umbrella offer some of the best, most widely tested, low to zero barrier to entry materials and instructor training out there. We've used software carpentry materials for everybody from advanced high school students through all of our research faculty. And me and several of my folks have gone through their instructor training. And that'll give you a lot of new insight into the literal science that goes into pedagogy and instructional design. Like a lot of y'all, I went through grad school. I taught some classes. I was basically handed some things and said, go. They didn't tell me why any of this would work or not work. And that's where I got some of that covered. The core curriculum in software carpentries covers the Unix shell, Git for version control, and then you got a few different options for either R or Python or data processing. And so that's a good core curriculum that anybody can take use of. Cyber ambassadors usually has a slot here. Henry, did they get one this year? So I can just keep the same notes as last year? Henry might have bailed on me, but previously Cyber Ambassadors has had a slot, and so I'll let them explain more in detail. But they are a recognized leader in training for some of the more soft skills. And yes, Henry does say that they're here on Wednesday. Okay, and so workshops in communications, teamwork, and leadership. In 2023, Dirk and the PIs were inducted into the ASEE, the American Society for Engineering Education Hall of Fame for their work on cyber ambassadors. Now, if you are more library oriented or need some help on that front, RDAP, the Research Data Access and Preservation Association, is for your data facing people, your research librarians. I am the child of a less fancy public school librarian. And so I love hanging out with librarians at their conferences. It's really energizing. And so at this point in the year, they should have just finished their annual conference. That QR code should go to a full set of conference materials for different things. And so good material that we're not going to find anywhere else in the more software and hardware focused ecosystems. Data carpentry, sibling to the software carpentry arm of the carpentries. They do a lot of more domain specific training materials, mostly in physical and social sciences. Some overlap with software carpentry, but it gets to be more focused on what they cover to match the needs of that specific field. So they will have ones for specifically how to do things specifically for geosciences or genomics or astrophysics. Library carpentry, this is the third of the carpentries organizations. This is more for your library and information professionals. They give out materials on how librarians can get more familiar with software automation, the sort of things that sort of are more second nature to the software facing folks, and so that they can promote those practices elsewhere at their institution. It's synergistic with the other carpentries areas and help your libraries provide a gateway to your RCD services because they may not know where you are, but they will know where the library is. And they do know that you ask librarians for things and they help you out. Software facing, the biggest organization in the pool for that, at least in the U.S., is the U.S. Research Software Engineering Association or the Research Software Engineer Association or the U.S. RSE. There's another one in the U.K. that's the U.K. RSE. Now, this is a ridiculously inclusive group. Not everybody is expected to be a professional software developer. They've handed me pens and things before, but they are absolutely where you want your developers, your specialty developers to be. There's a lot of software out there that we experience that's just good enough to get the work done, but doesn't scale up, doesn't scale out. Accessibility and other things can factor in sometimes. USRSE can help with that. USRSE and the Academic Data Software Alliance also a couple of years ago put together a career guidebook for data scientists and RSEs sort of combined because there's a good bit of overlap between them. And that nicely complements what CART does with broader RCD professionalization. You can find a link to that in USRSE's resources page. And then for systems facing, one of the predominant ones for that one, ACM STIG HPC Systems Professionals. This is a purely virtual chapter. This is the first group that I joined around 2018. And so I got hired into an enterprise IT systems administration group on account of my systems facing skills. And I'd run smaller HPCs for the university, for a dozen years prior to that. Even though that I'd been doing that at smaller scales, SIG HPC SysPros showed me a whole lot more that I could be doing and let me learn from other people's mistakes and successes. Now, demographically, this group is absolutely does not look diverse at all. They all look kind of like me, middle-aged white dudes. But it is still very welcoming and practically unstumpable on deeper systems related questions. They have a birds of a feather session and a social event every year at PERC, and 99% of their activity is around a professional level infinite history Slack that is my knowledge base for all kinds of systems administration things, where most of that activity occurs. And for training purposes, there's LCI, the Linux Clusters Institute. I've only attended one of their workshops as a last minute instructor in 2025, but it is regarded as some of the best training for your systems facing people to level up some of their HPC administration skills. And every time there's a new LCI workshop, they've got introductory, intermediate, and advanced ones, especially for the more introductory ones. We always see a new batch of people join SIG HPC SysPros all in a bunch, and we love to have them. Now, on the strategy and policy facing side, predominantly is CASC, the Coalition for Academic Scientific Computation. And so CASC is very much aligned around the federal funding landscape and the other, intricacies of dealing with that bunch of folks. And so it's got the closest ties to the federal agencies that drive a lot of our NSF, NIH type funding. And it advocates for the concerns and the needs of our RCD communities toward those agencies and toward the federal government at large. There is a membership cost on CASC, and it is an institutional membership. So it's on the order of, I think, $2,500 to $5,000 a year, depending on your Carnegie status. And so that is an exception for most of the groups that I've talked about so far. And their conferences are really not my comfort zone because I'm still not seeing myself, mentally as a director type. But they do have a very unique and role in the RCD system, and I am absolutely grateful that they're doing what I can't do as easily as they do. And another externally facing group for RCD is part of EDUCAUSE. And depending on where you're at and how you're structured relative to your central IT organization, uh, I will guarantee you your central IT organization almost certainly has an EDUCAUSE membership. Ours does. We've had it for forever. Even if you've never heard of them, if you're in a different group supporting research computing, EDUCAUSE has membership on your campus. And so the RCD group in EDUCAUSE gets a little bit farther afield than other groups in addressing support for the administration of research, your Office of Sponsored Projects type stuff, rather than the research itself. But they do also have an interesting niche between the RCD groups and the more enterprise IT groups in terms of sort of doing some of that, some of Henry's stuff of where enterprise and research IT are not the same. They can sort of provide that bridge sometimes. And then finally, the last group on there for the strategy and policy facing is the Regulated Research Community of Practice, or RRCOP or RCOP, depending on who you ask. And so that's the best meeting place for anybody that's working at the intersection of cybersecurity, compliance, and research. So all of your NIST 800 171 and CMMC and all of that compliance type stuff is core to RCOP and also to a related group, Trusted CI. And so if your institution is just getting into some more sensitive research areas, especially Department of Defense type things, RCOP can be an invaluable sanity check for everybody at your campus. Because, at times, security measures can go overboard in an abundance of caution, risk management, unknowns. But our RCOP can be basically a route to learn from people who have already been down that journey before you, gather up what more experienced institutions are doing to secure their more regulated data so you're not having to make it all up as you go along. And that is it for the first section. Let me do a real quick scan through comments to Veronica's question about state level groups. Yeah, Great Plains and Rocky Mountain both have regional groups. They're actually, Veronica, where are you? Where are you from? If you don't mind unmuting or type either one. Rose State. I have no idea where Rose State is. Where is it geographically? Midwest city near Tinker. I hope that means Midwestern the U.S. There is a Midwest Oklahoma. Okay. So Henry's going to be more plugged into that, but that probably is Great Plains. Because I don't know if there is. Henry has the one Okie type group that I think is a little bit more informal. And yes, Maximilian, yes, I am generally findable on LinkedIn, on Slack, on email. No problem. I'm reasonably Googleable. I may have my contact info somewhere in here, but if I don't, I can absolutely be found. Um, okay, let me get my others then. Which desktop? That desktop. Okay. All right. And because I'm never certain how we're going to run these meetings, I always have the first two slides at the beginning. And so you've already heard my hilarious stories about, my various lack of diagnoses and such. And so this talk is about the systems, providers, and technologies. So the hardware and the ecosystem that go around the people. Okay. And so there is a huge array of these out there. And if you just pick one at random, it may not work out well for you. And so rather than give you every bit of detail about every provider that's out there and run out my time limit, I'm going to basically show you some meta things on places that have sort of collected up and indexed how you can find out more about some resources. And then from there, you can sort of work your way around from there. And so the critical mass of NSF funded resources, and these are federally funded, they are 99% of the time or greater at zero cost to your institution or your researcher. And so pretty much all of the NSF resources nowadays can be found via the Advanced Cyber Infrastructure Coordination Ecosystem Services and Support System, or ACCESS. Okay. And so the Access Allocations Portal is your starting point for getting set up on Access, whether it's for yourself or your researchers. And I'll go ahead and say, uh, go ahead and get yourself an allocation. Ideally, join Campus Champions, and you get a little check mark that says this is a Campus Champions allocation. And they cut down on the paperwork you got to go through on a yearly basis to keep some things around. And you can use that to sort of pilot things alongside your researchers. Not for doing like your own research or anything necessarily, but more along the lines of facilitating and accelerating your end users' access into things. The first thing Access is going to want from you, though, in addition to just basically, for you to sign up for an account, you don't get access to Access until you set up a project categorization that leads toward a proposal. And so there's four different ones of them here: the Explore, the Discover, the Accelerate, and the Maximize. And I will tell you that the first two categories of those, the Explore and the Discover, have covered practically everything that me or any of my end users have needed in terms of bigger resources than we could provide here. Okay. And so do you have classes and training workshops? One of those two can almost certainly handle it. NSF graduate fellowship recipients. There is a spot explicitly in these programs to support the GFRP program. And if you're a smaller institution, and again, there's a sliding scale on that, even some of these Discover scale resources, if you tried to host those on site, they could absolutely overwhelm a small shop. And so please take advantage of these wherever it makes sense. Now, beyond that, with a corresponding amount of paperwork, Access can accommodate the highest scale of research activities. And so there's publications out there for black holes, subatomic particle discoveries, and other things that were facilitated and discovered via the compute resources that Access enabled. And I call back to the Exceed program occasionally, which was Access's predecessor. Exceed did great work in making things available to people, but there were some barriers to entry on it. You could only have one project at a time. Some of those projects would only get reviewed like once a year for a submission, and you couldn't do it year round. And so Access learned a whole lot of lessons from Exceed on how to do the allocations process. And so in general, anything but that topmost tier of Access allocation has a year-round submission window. You can usually get a yes, no back on that proposal within a couple of days and get actual set up on the remote computer within a few business days. Okay. The other nice thing with Access versus Exceed is that Access always awards things in terms of fungible resource credits, basically, service units, they would call them. And so you exchange those credits for resource hours at a given provider, whether that's NCSA, Pittsburgh, wherever. And if you decide that's not the one that you need, you can send the credits back, get them exchanged back, and then go somewhere else afterwards. And so you can make it, there's more room for you to make some mistakes without jeopardizing your researcher's progress in the Access system. And you can see here with the various four types of allocations, there's everything from an abstract paragraph all the way up to a 10-page maximum proposal to get the biggest of the allocations. And so you can get so much done on those two lower allocations, and you can have pretty much as many of those as makes sense based off of the research boundaries of what you're trying to support there. So request at any time, multiple projects. You can add on people as you need to get the work done. So while you're working on the documentation for the Access project that you're going to submit, you can also check out Access's resource catalog. The QR code there is fine, but if you go to accessci.org and look for the resources menu at the top, you'll find the same thing. And it has currently somewhere around 20 unique services listed. There is no way you want to go through those one at a time to figure out which one is which and which one you need to send your people to. And so they added this thing a couple of years ago when the Access program launched in the upper right-hand corner, where you can filter down in terms of some plain language of what you're interested in, whether that is a specific university or other provider, if it is a type of compute. If you are interested in GPUs and you absolutely have to have GPUs, you can filter out anybody that doesn't have GPUs. By the same token, if you're looking for novel compute, if you're looking to avoid GPUs, you can use those filters as well. Okay. And so use those filters, click them on and off in any way that makes sense to sort of narrow down the resources that you might be interested in. And then once you've got your smaller list, you can click on those bold underlined links to get more information about that particular resource. And so I'll give you a survey of some of either the newest ones or the most interesting one or the biggest ones on the list. But by all means, you should go through a bunch of the filtering options to figure out what works best. And then you can reach out to Access or other people in the RCD community for advice if needed. And so one of the newer systems in terms of an entire product launch is Delta AI at the University of Illinois Urbana-Champaign at the National Center for Supercomputing Applications, the NCSA. And NCSA is basically the motherland of all academic supercomputing for me. And so Delta AI, very GPU heavy, for any and all accelerated simulations, AI, deep learning, similar applications. And so, 600 H100 GPUs is a lot. Okay. Alongside Delta AI at NCSA is Delta without the AI. And so this one is more general purpose. It's still fairly GPU heavy, but it's not specifically focused on AI applications. Most of these machines do not contain the absolute newest, most bleeding edge hardware, but having 800 plus ampere GPUs versus the 20 that I've got here is absolutely nothing to sneeze at. And they added on another 64 in the last year, another 64 H200 GPUs, which are practically top of the line for that. And that's a serious upgrade for them as well. Now, the one of the other main ones in terms of just sheer volume is the Texas Advanced Computing Center at UT Austin. And so their main one that's currently completely publicly available is Stampede 3. And so that is absolutely enormous. 1,800 nodes, a mix of NVIDIA and Intel GPUs, high bandwidth memory, extreme scale memory, high speed networking. They will take your jobs that need tens of thousands of cores to run. They'll take smaller size jobs. They'll take throughput computing. And Stampede 3 has been around for about 3 years now. Successor to Stampede and Stampede 2. They added in some H100 GPUs in the last year, and they've got at least one or two other really big supercomputing projects in the works that are not quite they're not on the Access list yet, and I don't think they're both quite in production yet, but we'll see what happens for next year. Another one, a bit smaller scale, but still plenty of resources, is Bridges 2 at the PSC, the Pittsburgh Supercomputing Center. PSC is jointly managed by Carnegie Mellon and the University of Pittsburgh, and this is a long-standing resource across the Exceed and the Access days, possibly back into the TeraGrid days before I started paying attention. Not every bit of this, again, is bleeding edge hardware, but they do have some nodes with 4 terabytes of memory for your massive graph searches or your massive bioinformatics type stuff. There's just not too many of those 4 terabyte machines around. They have recently beefed up their GPU capacity. They've got a few nodes that have a total of that have each have 8 of these NVIDIA L40S cards in them. And so those are super economical cards for PSC for the inference work that a lot of us end up using GPUs for versus the training work. And so a big heavy A100 or H100 or similar for purely inference is a little bit of a waste in terms of the amount that it costs versus what you get out of it. And so they also installed some 8 GPU H100 nodes last year. And Bridges has long been sort of the go-to resource for a lot of the stuff that we do here when we outgrow things, or if a backhoe takes out my data center power like it did a few years ago, and I was out of commission for about 6 weeks. Now at Purdue, Anvil, this one sort of straddles a line between traditional simulation and private cloud workloads. Okay. And so one unique thing with Anvil is what they call their composable subsystem. And so if you have users that have sort of already structured their work, or you can help them structure their work into a very containerized Kubernetes sort of packaging, they're basically the only place that I can think of that will basically run Kubernetes workloads for you for inferencing, for specialized large language models, for science gateways, and anything like that. That's their main thing. There is the Kubernetes composable infrastructure. Also, more on the cloud side in terms of how it's architected is Jetstream 2 at Indiana University. And so this is a private cloud environment. It is predominantly focused on two things: on demand, sort of interactive usage of virtual machines, particularly for people who just want to do bigger interactive data science, but don't necessarily want to mess with a batch scheduling system and other things that go with a traditional HPC. Now, it runs OpenStack on its back end. You can use it for those interactive services, but you can also use it for long running virtual machines for any kind of research infrastructure, especially if those VMs are not computationally intense, but they need to run a database or an API service or something where it needs to be available. It needs to be running all the time, but it doesn't need a whole lot of CPU oomph. Okay. Now, if you do have something that's computationally intensive, Jetstream 2's hardware is no slouch. You know, it's got AMD Milans, it's got A100 GPUs, 360 of them. You've got up to 1 terabyte of RAM in different machines, and so you can do more computationally intense work there. And I'll tell you, a couple years ago, I ran a workshop at the PERC 24 conference, and I had to build 30 small HPC environments, one for each student attending the workshop. Jetstream took that workload like no problem whatsoever. I absolutely would not have been able to conduct that workshop without them, and so I am super grateful to them for the help they gave me in getting that running. Now, CloudBank. CloudBank was mentioned in these slides many years ago before I took them over. And I don't know exactly why they were excluded, but I'm putting them back in this year because for a few reasons. One, we as a community are broadly research, computing, and data people versus strictly HPC people. Okay. And so I think it's worth looking at some cloud options for certain use cases. But also, in the last year, the second version of CloudBank launched, CloudBank 2. CloudBank 2 is fully integrated into the access allocations and other access ecosystems, just like Bridges and Stampede and some of the others. They have training materials. They get you resource allocations on multiple commercial cloud providers, currently Amazon, Google, IBM, and Microsoft. Oracle is marked as coming soon. I don't know when. All of that is at zero cost to the PIs. You know, they've got funding. They are sending that funding to a cloud provider on your behalf. Now, running a lot of workloads in the cloud is stupidly expensive compared to owning your own hardware or compared to using a federally funded batch resource. Uh, but CloudBank not only provisions raw compute and storage for you, but they also facilitate getting access to various platform as a service type things that are proprietary to those cloud providers. And so databases, big data and analytics tools, machine learning infrastructure, all of that kind of stuff can be facilitated via CloudBank too. CloudBank also is now partnering elsewhere at the San Diego Supercomputer Center with their Sherlock group. And the point of Sherlock and CloudBank 2 getting together is to help other institutions configure secure enclaves in cloud environments for regulated data. And so for those of us like me that don't have secure enclaves for HIPAA, FERPA type data, we can leverage their expertise when needed. Now, I will fully admit that from what I've looked at in CloudBank, since they are paying an operational expense for you, they ask you to do quite a bit of homework to help economize what you're asking for in terms of virtual machine size. Do you want it on demand versus 24/7? Can you live with being interrupted and things like that? And so a lot of that fiddliness is still on you and your researchers to kind of work out to have a smooth experience. But if you do have limited budgets, CloudBank may be a perfectly good, maybe the best way to use some of the commercial offerings without having a whole lot of risk. So last on my access list is the ACES facility at Texas A&M. Now, this one is also a little bit different than the NCSAs, the bridges, and the TACs, in that ACES's niche in the ecosystem is software-defined architectures and composability of resources. It is actually not a particularly large environment in terms of pure HPC. 130 nodes, about 12,000 cores. You know, again, I'm small out here, and I'm on the order on the order of a third to a half of that node count, and about a quarter of that core count. And so it's definitely not your big number crunching area. But the fact that you can mix and match a whole bunch of GPUs, FPGAs, coprocessors, Optane memory modules, all kinds of things into a weird sort of Frankenstein system to do your weird research on, that is the go-to resource for that. Uh, and so it's an incredibly flexible facility for a lot of uncommon use cases. So again, your basic simulation, send that somewhere else. But if you've got your electrical engineering or your computer architecture type people, this might be the place for them. Okay. So the other federal agency that I think of for scientific research is the Department of Energy. And so Oak Ridge National Lab, I co-opted there 30-ish years ago. They're about 90 minutes away in terms of a drive time for here. And we've had close relationships for them for graduate programs, for collaborative research, all kinds of things. And so Oak Ridge's Leadership Computing Facility, the OLCF, is part of the Department of Energy's Advanced Scientific Computing Research Arm, or OSCAR. And so access may not be the best fit for all of the research that your faculty want to do. And so especially if there is a DOE interest in the research that your people are doing, Oscar is absolutely worth giving a look, because you could get access potentially to some massive resources compared to those, because the DOE tends to keep the fastest or second fastest computer in the world, not just the US, not just academia, but worldwide on a pretty regular basis. And those facilities are often available via Oscar. And so there's four main avenues into your Oscar resources. Each one of them is a little bit focused a little bit differently. Gives you access to different facilities. And so the Insight program is hosted from Oak Ridge and Argonne National Labs. This is predominantly for open science applications, so no national security type things or anything like that. But they also need to scale ridiculously large. They at one time they said this needs to be able to scale to take up the majority of the resources of a top 10 global HPC environment. And so that's a lot. But if you can hit that target, this is great. This is game changing for you. The ALCC, this can be done on a year by year basis based off of if your research aligns with DOE missions, or if it helps broaden the community that can make good use of HPC facilities at either Oak Ridge or Argonne or the NERSC lab at Lawrence Berkeley. Okay. And so that's another route. The ERCAP is specific to the NERSC laboratory at Lawrence Berkeley. That is for projects that just align with the Office of Science priorities and SBIR, STTR type relationships with NERSC. And all of those centers also have a small amount of resources left to each facility director's discretion that literally fall into what they call director discretion or center reserves. And so those tend to be, smaller chunks of things. But if you need a little bit of a world leading supercomputer for a small part of the year, that may still be a good fit for you. And all of these programs, also any of this blue stuff you see in the slides is generally a hyperlink as well when you get the PDFs. And then, last but not least, I think on my federally funded list is the National Artificial Intelligence Research Resource, or NAIR, pilot program. I think in the next year, NAIR is no longer going to be considered a pilot. I will say that when NAIR first started, NAIR basically dual purposed a lot of the director discretion resources at a lot of existing federally funded facilities to basically have an extra route in for specific AI focused projects. And so as a result, in a lot of cases, I would say if you had a choice between a NAIR resource or a NAIR process and an access process to get the same work done, I would normally move myself toward the access process just because it was simpler and you had more facilities available. However, similar to CloudBank being the only or the best place to go if you want to have zero cost access to, like, Amazon inference services for AI, NAIR is unique in that they have also partnered up with something like 25 non-governmental or commercial partners all over the AI and cloud hyperscaler markets. And so if you need something more than just raw compute cycles, if you need open AI tokens or access, if you need Samba Nova inference services, all kinds of things like weights and measures or weights and balances type models, things like that. NAIR is the zero cost route to a lot of proprietary things that your researchers might be interested in. Now, if we go on past the nuts and bolts and we go into people time, so services and consultancies, Access offers a few different options for this. And so Match Plus can be an absolute lifesaver for an under-resourced research project or for new users. And the whole point with Match Plus is they take requests from any researcher with a need for computational help. They will then match them up with both a student and a mentor for that student to provide that support. And so the engagements in a Match Plus are typically 5 to 10 hours a week for the student, 2 to 3 hours per week for the mentor. And those can run for anywhere from 3 to 6 months. And from that, There's projects where it's helped me scale this code that runs on my desktop or laptop up to an introductory HPC scale. Help me identify bottlenecks and optimizations in this existing code, or getting extra assistance migrating a working workload to an access resource. Zero cost to the researcher, and so please make use of them if they look useful to you at all. Again, return on investment. Any return for zero investment is infinite return. Now, if you have a project that has budget and needs basically, a consultant or what some of my coworkers would call a sharpshooter in a particular area, Match also offers a higher tier called Match Premier. And so if a project is more at the level where they need help from a postdoc or a research scientist, but your institution just doesn't have those available on a full-time basis, or at least not available in the time that you need them, Match Premier might be a good option. And these are basically just paid engagements between the researcher that needs the help and an expert consultant, and Access just facilitates making those connections. And so it's a way of getting a fractional research software engineer or other expert on hand for your project without having to go through the full hiring process for them. There is also, not at the individual project level, but more at the institutional level, is the EPIC, the Engagement and Performance Operations Center. And their goal is to identify and reduce bottlenecks in network performance, data transfer, and similar areas. And so they have a roadside assistance type service for reactive troubleshooting of network problems. They do what they call application deep dives that look more closely at your application workflows, at science DMZs and other areas to evaluate bottlenecks and potential capacity issues in a more proactive way. And they also have different network monitoring tools like NetSage to more proactively discover and resolve performance issues before they become critical. More on the software engineering side of things than the network and system side of things is the Science Gateways Community Institute and the SGX3 Center of Excellence. And so science gateways are usually web-based interfaces to computational resources. They can greatly reduce the barriers to entry for those resources, but they're often not things that most of us are going to write, fluently and competently, because that's a whole area of software engineering that has nothing to do with our research areas. And it's just about doing like professional, modern web and application development. Now, Science Gateways and SGX3, they've got interest in workforce development, in broadening the community that uses advanced cyber infrastructure, providing expert advice, and steering future software and gateway development practices to make things better for all of us. In the sampler pack of tools and software that have made my life better over time, and all of these I have direct experience with, and I do not want to live without them at this point. The OpenHPC project, absolute lifesaver for me. OpenHPC is a completely free and open source suite of components for building HPC architectures with a minimum of effort. OpenHPC, I have run everything from on a laptop for my student workers out to our production HPCs. Our high school students do that kind of thing. We have a little demo cluster that sits on a cart that runs a visualization in real time across multiple computers in that cart. And so all of my student workers have generally gotten OpenHPC up, running, and accepting a job on a laptop within a working day. Little bit of guidance sometimes. And so if your original or existing HPC environment was sort of a turnkey vendor product, if it's running out its support life cycle, if you weren't getting a huge amount of value from the product that your vendor was offering you, OpenHPC might give that perfectly good cluster in terms of hardware, might give it an extended lifespan. And so you can focus your budget on hardware and local people versus licensing fees for the institutions where that makes sense. OpenXDMod from the University of Buffalo is a basically one-of-a-kind tool to quantify your HPC's usage trends and then communicate that clearly to your researchers, to your leadership, or other stakeholders. And so the thing with OpenXDMod for me is it has helped me stop so many conversations that started out with, quote, I'm not getting enough access to the cluster, and wound up in a much more productive direction as a result in terms of, well, why aren't you getting access to the cluster? You know, is it that we are full? Is it that we're not full, but you're not submitting jobs, or your student aren't submitting jobs? Are they submitting jobs in such a way where they can't run quickly, but they just massively misestimated what they need, and we can help them get that right sized? Also, completely free and open source, long history of development and support. New release came out earlier this year, I think. And this is one of those tools that makes an under-resourced institution look more professional. And the Access Project runs XDMod as well to present all of their statistics to, you know, the public, to their end users, and to campus champions. And so this is good stuff here. Open On Demand from the Ohio Supercomputer Center. Outstanding tool for making things easier on your new users, and a lot of your more experienced users are going to like it as well. And so this focuses on providing a web interface both to your HPC users' files, web-based terminals purely in browser to your login systems, job monitoring, graphical access to compute nodes if you so choose, and let you build or use existing application forms to streamline common computational tasks. Your security people are going to be happy that it can be integrated with the same multi-factor authentication that supports your ERP system and your email and other stuff. And you are probably going to hear good things about your users from it, just in terms of lowering that barrier to entry and that time delay for them to run their first job. And then my last tool is SPAC. And SPAC is they just had their 1.2 release, I think, literally last night. This is a framework and tooling for building software packages from source. It does all of the dependency management for you. It integrates with the module system that you might use to allow users to load and unload software on an ad hoc basis. And it makes it so much easier to get optimized builds of any computational tools compared to what you might get with the simplest, configure, make, install type of commands. SPAC normally offers full day workshops at PERC. All of their training material is online, but I will say that it is absolutely worth it, I think, to attend their workshop at least once, because that helped me and some of my folks get past a few hurdles there. And, Henry, I am done with slides, and you may be done with me.
Well, this would be a great opportunity for some questions then.
We have love for OpenHPC and SPAC. How does one pick between SPAC and OpenHPC? Okay, Sean, I know you know that those are different types of products. Are you asking which one I love more?
Yeah, somewhat. I mostly just throw
Okay.
that out there because for some reason it's the question everyone asks me,
Mm.
and that I have to start explaining that they're different, and
Yep.
I usually wander off and give a poor explanation.
I would say SPAC is great after you have a working OpenHPC. Now, you can use SPAC, honestly, to build things just like directly on your MacBook or something as well. So that is one other thing where you could use it as your general purpose software build environment for computational tools, regardless of if they're on an HPC or not. That's not something I'm commonly doing, but it is absolutely something that they support.
Okay. And
But SPAC is not a
OpenHPC
scheduler.
more, right, exactly.
SPAC does not handle how your compute nodes get their software. It does
Right.
not handle authentication. It is software building.
No, good. No, that's a
Yeah.
good answer. Great. Thank you.
Yep. What tools would you recommend for a Beowulf cluster? A Beowulf cluster to me is any collection of computers that can be turned into a cluster, and I would honestly start with OpenHPC. I've got some other materials on OpenHPC from a workshop that I did last week. If you give me a second, I can probably, I'm not going to go through the whole thing, um, but I will find a couple of things that might help narrow that down. Uh, 1 second. So let me take the screen share back as soon as I find it again. Okay, so, and I've lost the name already. Sayura. Okay. Yeah, and Carlisle says, I've mentored CS seniors to build an HPC cluster from scratch using OpenHPC and retired hardware. And then Sean talking about Open Nebula. Yeah, for another thing. So, Sayura, the basic point with OpenHPC is it is a community and set of basically structured packages around a selection of operating system and scheduler and provisioner. And if you're not familiar with the term provisioner, the thing that installs the operating system on your compute nodes and your compute capacity. And so these are the currently supported versions of things in the Open HPC ecosystem right now. And so Enterprise Linux 8, 9, or 10. And so whether that is Red Hat, Rocky, Alma, uh, OpenSUSE, uh, Leap, a couple different versions of that, Open Euler, which is a Huawei Chinese variant of some things. You can pick your scheduler between OpenPBS and Slurm right now. I would say 99% of people pick Slurm. And then you can pick your provisioner. A lot of people probably end up on Werewolf 4, which comes from some of the same people that made Rocky. But that is absolutely not a requirement. I would probably go with 4 over 3. Nobody really wants to run Werewolf 3 anymore. OpenShami has some traction in the DOE for some reasons. And then Confluent, I think, is the successor to an older product called XCAT. But the thing is that any of these available combinations of operating system, provisioner, and batch scheduler, there's an installation guide that is well tested for every one of those entries on the table. And I would say, given one computer with 2 network cards, another computer with 1 network card, and a dumb Ethernet switch you can drop between them, it's possible to build an open HPC architecture off of that inside of a day. If you know if you know enough networking to know how to get the 2 computers to talk to each other over the switch, you know. And I've got a few slides of that. Yeah. So our production cluster, our high school students from a few years ago building off of cast off desktops, and then our little demo cluster down here in the lower right hand corner that is 5 Lenovo cast off teaching systems running a very odd combination of a scheduler and a parallel simulation and a visualizer. That is a very odd cluster in terms of how clusters normally run because of the visualizer and other things, but it's a great demo for us. And all of that is Open HPC. Anything else? And yeah, as for the title of that set of slides, theoretically, if you have enough automation tools built up on your laptop in advance, you can have an Open HPC cluster up and running within about 10 minutes.
Yeah, I'll say I definitely do everything on my laptop first
Yeah.
before doing it elsewhere. It's so handy.
Well, anything else? All right. Well, Henry, whatever you want to do to close out.
All right. Thank you, Mike. And I'm going to go ahead and stop the recording.